I can, if I have to look back and know that you were not here or that you were late, I do. And so,
Girl, not your notebook. The stack of paper. I have it in my notebook.
okay. All right. All right. Cameron, was it something I said?
Huh? Yeah.
Was it something I said that you had to move?
Yeah.
You know that's the wet seat, right? That's where Jules drips all of her water and stuff. Just so you know. Just so you know. All right. Okay, so let's begin with this today, ladies and gentlemen. Uh, does anybody have any questions on the things that are going to be on today's quiz? On measurements? Yes, Jules.
Oh, never mind. You're gonna finish my question. I was wondering what was on the quiz.
Okay. Here's the honest to goodness truth. If at this point you're asking what's on the quiz, you're probably in trouble today. Okay, I'm just pointing that out. Because again, it's been on the board for over a week. But again, you're going to have it's a 20-point quiz. Going to be questions on the vocabulary, constant, control, experiment, direct, inverse relationship, hypothesis, qualitative, quantitative observation. Those definitions that we gave you at the start. Any questions on any of those definitions that we gave you at the start? Please remember, anything that you want to write on your yellow periodic table, on your pink solubility chart, you are welcome to do so, and you are welcome to use it on the quiz. There will be no conversions on today's quiz. So not going from centimeters to meters, not going from kilometers to meters, nothing like that. Okay? The other thing that will be on there, though, are the measurements, as far as understanding how unit, measurement, and type of measurement go together. So I will give you a question, and it will say, what instrument do we use to measure grams? A balance. If we have the unit, if we have an instrument of a stopwatch, what does it measure? It measures time. What unit do we measure time in seconds? That's the kind of thing that will be on there. So it should be fairly easy for you. Okay? Questions? All right. Now, yesterday, ladies and gentlemen, we started talking about accuracy and precision. Okay? In a minute, did we get through all four instruments yesterday in the back?
Mm-hmm.
Okay, good. Then you guys are ahead of my other classes, and that will be fine. All right. Want to take a look at something for you, ladies and gentlemen. Again, I don't collect homework from you, okay? I'm not going to. But on this first page, ladies and gentlemen, here are some problems on accuracy. Now remember, accuracy is how close you come to hitting a target. So this is the first question on the worksheet. Of these four measurements here in the black, which one is the closest to this target of 100.0 degrees Celsius? Which one of these four is the closest to it? 100.3. Now, how do we know which one is closest? It's simply which one is the closest value to it, and it doesn't matter if you are above or below the value. So 100.3 and 99.6 are the two closest values to 100. This is off by 0.4. This is off by 0.3, so the one that's the closest is 100.3. Any questions on that? Okay, so that is what we mean by when we're talking about accuracy. Again, first thing you have to be given, though, is your target. The density of glass is 2.5 grams per centimeter cubed. Okay, we've got four measurements here. Now, here's the easiest thing for you to do with a problem like this. When you look at those measurements, ladies and gentlemen, which two are closest to 25.0? Which two are the closest to it? Of the four measurements here. The last two. So this is closer to this one?
No. The 2 with the 3.
The 2 with there's 2 of them that are a 2 with a 3, Jules. So which numbers are closest to this? Well, this number is bigger than this one, correct? And they are both below 2.5. So that's the one that's closest, correct? Of just these 2 numbers, right? Now, the numbers that are above 2.5, these are the 2 that are closest. These last 2, which one is smaller? This one. So what you're really debating between is this one and this one as to which one is closer, ladies and gentlemen. Okay? Now, you got to be careful. These 2 are very close. Very close. Which one of these 2 is closer? This one is off by 0.141. This is off by 0.14. So the correct answer would be 2.36 grams per centimeters cubed. Questions? Okay? All right. So that's how you go about those, just so you know, ladies and gentlemen. Just so you know. All right. So now here, ladies and gentlemen, you're looking at these 4 numbers and you're asking yourself which is the most precise. Well, I will tell you, you probably are going to struggle with this first one and the fourth one, ladies and gentlemen. And the reason you're going to struggle with those 2 is because we haven't gotten to numbers like this very much yet. We're going to talk about these today. It's something called sig figs. We'll get into that. But let's go to this one. Which of these 4 numbers is the most precise number? Okay, or let me rephrase that. Which of these 4 measurements is the most precise measurement? Alicio, which one do you think?
700.
No, let's look at the next one, please, sir. Let's not do that top one. Let's not do that top one because you don't have the information yet to do the top one or to do this bottom one. So this second one, which is the most precise number of these 3? 16.3, 16.25, 16.000, 16.30. What? Is the most precise?
Yeah.
Nope.
Is it
Right?
16.000?
16.000 is the most precise. Why? 3 places beyond the decimal. 2 places, 1 place, 2 places. This is the most precise measurement. Now, again, we're looking at precision in this case as being the sharpest measurement. The sharpest measurement. That is what we are looking at, ladies and gentlemen. Questions? Okay, so now we go down to this one below. Now, again, these numbers are very different. Their values are around 14 and around 210. Okay? Which of these 4 numbers down here do you think is the most precise number in that group? Finley, which one of these 4 do you think is the most precise number? 14.5 milliliters, 210.00, 14.0 milliliters, or 210 milliliters?
210.00.
Thank you. 210.00 because it goes to 2 places beyond the decimal point. Okay? That is the most precise measurement out of these 4. Questions? Okay. Now we get to these where precision, we are talking about how close a series of measurements are. Okay? So again, we began talking about accuracy. Then we talked about precision being how sharp a measurement is. Now we are talking about precision being how close these measurements are together. So for that, ladies and gentlemen, I did something to help you with this problem. I said, all right, what is the range? Okay. So I asked, what is the range? So to find the range, we find the highest and the lowest value of those in Group A. Albert, in Group A here, which of these numbers is the biggest number of these 4, I'm sorry. Okay. Which one is the lowest of these 3, Estefani?
272.
Very good. So now what we do is we subtract these 2. That is a difference of 1.6. Okay? We go to our Group B. Which one is the largest number in group B, Elsa? Which one is the largest number in group B? Okay, that's our high. How about the lowest number in group B, Abigail?
272.
All right, that's our low. That is a difference of 2.0 or 2. We could have done it either way. Fair enough. Cameron, in group C, which one is the highest number? Sorry, which one is the highest? 270, which 0.9? I'm sorry, I didn't hear that. I didn't hear your number because there's two that are, I heard 270.9. I'm sorry, I missed that. Thank you. I just missed that one digit. I'm sorry. All right, what is the lowest value here, Theodore?
Could you read out the numbers out loud?
272.1, 272.9, 273.0, 273.9.
First.
Okay. By the way, this is on your worksheet. If you got that packet, you could take it out. Okay. So we subtract those, ladies and gentlemen, and we get 1.8. Okay. Finally, we look at our last one, group D. Okay. Which one is the largest number in this group, Sam? 273.60. That's the highest. The lowest, Evelyn, in this group? 271.00. That's a difference of 2.6. So of these four, which one is the closest group of measurements together, Giselle? Not A. Well, it's either A, B, C, or D. So when you look at the range here, which one has the smallest number here, Giselle? A. So that is our winner. That is group A. You're right. Group C is the second one. But that is how we look at precision of a series of measurements. Are there any questions on this? Okay. This, again, is not going to be on today's quiz. Okay. Just wanted to show you that because that is what we talked about yesterday. Questions at all? Okay. All right. So, ladies and gentlemen, we showed you yesterday how we go about taking measurements. Okay. Now, when you get an instrument and when you are looking at an instrument, the hard part for an instrument is determining what place it reads to when you look at it. Okay. So I've got a ruler here, ladies and gentlemen, and it's got some markings on it. Now you can clearly see 1 through 30 on here, 1 through 29, correct? So we know for sure that's the ones place for sure. So when you find all of the markings in a place, so if it goes 10, 20, 30, 40, 50, 60, 70, 80, that's the tens place, right? 100, 200, 300, 400. This happens to be the ones place on this side, right? Then you ask yourself, okay, between 11 and 12, are there enough marks that I know the tens place? Because that is a little bit more precise than the ones place. So in other words, can I find 11.1, 11.2, 11.3, all the way to 11.9? And on this ruler, you can find those places. There are 9 marks in between 10 and 11, or between 11 and 12, or between 12 and 13. There are 9 marks each time. So you've got the tenths place here. So this instrument reads to the tenths place. Because of that, ladies and gentlemen, you can record an answer to the hundredths place. You're allowed to estimate one place beyond what you're sure of. Okay? And here's what it amounts to. When you take a measurement, and I'm going to zoom in on this. Okay? When you take a measurement, and I measure the width of this piece of paper, I am going to come up with a measurement that is between 2 numbers. So number 1, I know this is between 7 and 8. No questions there, correct? Now, I also know that it looks like it's between 7.6 and 7.7. Okay? So this kind of ends, in my opinion, a little bit after this line. Now, you may say it's right on that line. That's still fine. But I'm debating between a number between 7.6 and 7.7. So that means I get to go to the hundredths place. I get to go 7.61, 7.62, 7.63. and you get to estimate that place. And no one can really argue with you on your estimated place. Okay? You're allowed to pick whatever digit you want to go in that place. Now, obviously, when your marks are very close together like here, you're going to have a hard time estimating. You are. But the important thing is that when you make a measurement in science, I have to at least get to that hundredth place. So I could write 76.0 and be good. I'm done. Well, 76.0. Thank you. Centimeters, and I can be done. You can't argue with me because it's very close to that 7.6 line, right? But Jules could go, I think it's 7.61. I'm not arguing with her. 7.61 centimeters. Ray could be 7.62 centimeters. You are allowed to have some estimation. Now, which one of the three of us is correct? We all are. But I wrote down a number that was different than Jules, who wrote down a number that was different than Ray's. How can you do that? Well, that's the third thing shown in every measurement. What's the third thing shown in every measurement after a number or a quantity and after a unit?
Precision and uncertainty.
Uncertainty. Uncertainty means he got to call the last digit 0.02. Jules got to call it let me rephrase that. 7.62. Jules got to call it 7.61. I got to call it 7.60. Uncertainty is always in the last sig fig or the last measured digit of a number. Why? Because you get to estimate it. That's called uncertainty. You may call it a different value than someone else. Doesn't mean you're right, doesn't mean you're wrong. It means that was your estimation. So every time you get an instrument, ladies and gentlemen, you need to look at the instrument and say, okay, I'm debating between this number and this number, and I get to pick where in between there I think it is. Okay? I get to pick where in between there I think it is. Now, if you're looking at something like this, okay? Here's 8, here's 9, here's 10. The ones place clearly marked out again, right? Here's 8.1, 8.2, 8.3, 8.4, 8.5, all the way up to 8.9. There's the tenths place. And in this one, because these are a little bit more spread out, maybe you make a little better estimation into the hundredths place, because that's where you go with this instrument. So that comes out right between 8.6 and 8.7, so Jewel calls it 8.65. But Sam calls it 8.64. Theodore calls it 8.66. Again, you're all correct. There's no problem with that. You're estimating that last number. But you got to be in that hundredths place because this instrument goes to the tenths. You go one place beyond the precision of the instrument. There is an exception to this rule. What is it?
Digital instruments.
A digital instrument. A digital instrument, all you do is write down what the display tells you. Questions? Okay. I'm going to go into your EISN right now. I would suggest you do the same, ladies and gentlemen. So in your EISN, I am looking for you to be on slide 31. 31. That matches my slide 38 here. My slide 38 is your slide 31. I'm sorry, our numbers are different. Okay? So this thermometer, what place do you clearly see right away marked out on it? What are the big numbers on there? Tens. 10, 20, 30, 40, 50. Marked out in tens, correct? Okay, are there any numbers between 20 and 30? Any marks? How many?
9.
Okay, so what place is that?
Ones.
The ones. Is there any mark between 21 and 22? Are there any marks on this instrument between 21 and 22? There are? Here's 21. Here's 22. Are there any marks in between there? So what place is this instrument reading to? the ones. Here's 21. Here's 22, 23, 24, 25. Reading to the ones. Now, what place do we write an answer to? Do we write a measurement to with this instrument? Now we go to the tenths. Now we go to the tenths. So again, you're looking at this level of the liquid here. When I look at it, I come over here, I say it's between 24 and 25. Okay? Maybe somebody else, it actually looks really close to being right on 24, doesn't it? Okay, give me a number near 24 to the tenths place. Give me a number near 24 shining to the tenths place.
25.0.
Good. Give me a number near 24 to the tenths place. Skylar. 24.1. Give me a number a little bit less than 24. A little bit less than 24, Kevin. 23.9. Sorry, I was looking at you, Sam, and I called Kevin. I'm sorry. Okay? Any of those are acceptable. If you think it's right at that 24, any of those numbers are acceptable. Okay? As long as you're close and as long as they all go to the tenths place. Okay? Why? Because now you're telling me, who looks at the measurement, that your instrument read to the ones place. That's why you went to the tenths. You went to the tenths because your instrument read to the ones. I can tell the precision of your instrument. That is that third thing shown in every measurement. Precision and uncertainty. Uncertainty is the fact that we got three different numbers. 23.9, 24.0, 24.1. They're all fine. Uncertainty is, okay, we're not sure of that last digit. Precision says, well, the instrument had to read to the ones place, that's why they're going to the tenths. Questions? All right. All right, what place is this ruler marked out in? Ones. Anything between 8 and 9? Any marks? So it reads to the ones place. What place would you report an answer to with this one, Elsa? To the tenths. So that line is right around 8, correct? Evelyn, how could we report it? Give me a number around 8 to the tenths place. 8 point what? 8.0. If you think it's right on the line, 8.0, absolutely fine. Absolutely fine. Karina, give me another one close to 8 to the tenths place. 8.1. 8.1. Could we say 7.9? Yeah. Okay. We could say any one of those numbers, ladies and gentlemen. Why? The ruler is reading to the ones place. We have to go one beyond that, to the tenths. Any number that is close to 8, 7.9, 8.0, 8.1. Now, what if somebody said 8.9? Cameron, you're shaking your head. No, why? Yeah, I mean, there's a pretty big gap here, right? I mean, if it's in the middle and you're giving me an 8.3, 8.4, I'm okay with that. If you look at this and go 8.9, I'm going to go, no, sorry, you're not close. You got to be close. You got to be close. Fair enough? Okay. Place does that instrument read to? Hundreds. So now, ladies and gentlemen, we need to find a measurement for that. In what place? If it reads to the 100s, 100. Tens, 10, correct? So we know it's more than 300 and less than 400. Give me a number between 300 and 400 to the tens place. 350. What else? 360. Anybody else? 340. I'd even take 370 or 330. It's kind of in the middle. A little harder to estimate, right? That's why sometimes they'll have a mark in between there where 350 is. Not to make it so that you can be more precise, but to help you estimate. Okay? To help you estimate. Any of those that you just gave me would be good. 340, 350, 360. Please remember to put a unit on it. Questions? All right. So again, this is a small section of a graduated cylinder. 30, 40, what place is that? Okay, what are these marks? Ones. And they're all there. 31, 2, 3, 4, 5, 6, 7, 8, 9, correct? Okay? So what would the reading of this measurement be, Jules? Well, first of all, what line is it very close to?
What do you mean, what line?
This right here.
Oh.
I'm sorry, this is supposed to represent the
Okay,
liquid.
Okay.
That's that meniscus that we get. What's that very close to?
30, 36. Look, this.
The bottom of the
Oh,
meniscus.
the
Sorry,
bottom?
sorry, my bad. The bottom of the meniscus is what we read to. So you see this curve shape here?
Oh.
The very bottom of it is what we read to. What's that very close to? What number?
35.
Okay. So now if this is reading in the ones place, Jules, what do we have to do to your number? Make it go to the... So give me that number to the tenths now. This isn't hard, Jules. Just relax. Take 35 and express it to the tenths place. Okay, I'll take 35.1. Aiden, what else would I take?
24.
Well, not 20.
34.
34.9. Okay? 34.9. Zach, what else would I take?
35.0.
You got it. You got it. Any of those are fine. Not the 24.9. The 34.9. Any of those are fine. Questions? All right. So, uncertainty and precision is the third thing shown in any measurement. Shown in any measurement at all, ladies and gentlemen. Okay? Uncertainty is always found in something that we call our last sig fig. I know I'm a little bit ahead. We'll get to sig figs in a second. It is always found in what is called the last sig fig. It is the number that you estimate. It's the 35.0. It's the 34.9. It's the 35.1. It is the last digit in those numbers. So if your measurement is 3.36, which is the number that you estimated in this measurement?
6.
The 6. That is your uncertain digit, and that is the last sig fig. That is the uncertain digit. Always the last sig fig. What about 14.200? Which digit is, which one, Cameron? Which one, though? There's two there. The last one. Very good. The last one. Okay? The last 0 is the last sig fig. It is also the uncertain digit. Why did we put these zeros down? Because we measured them. We measured them. Okay? We got to that place, we measured them. All right. 0.0209 grams. Which one is the uncertain digit?
9.
The 9. The last sig fig. Now we're going to skip that one because we need to talk about sig figs first. Okay? We're going to skip that one because we're going to go to sig figs first. So let me jump ahead. All right. So, hang on. Yeah, I'm doing very well today, ladies and gentlemen. Okay, so let's quick talk about sig figs, because I can't go back through that without talking about this first. All right. There is a thing in science called sig fig, and there is a difference between a number and a digit. Okay? That entire thing is one number. 1,342,365.1427. That entire thing is one number, correct? And it is made up of 11 different digits. Each one in a different place on the number line. The 1 is in the millions place here. The second one is in the tenths. The 4 is in the 10,000ths place. This 4 is in the hundredths. Each one of these digits is in a different place. Okay? A number is a single value used to represent a measured quantity. That is what a number is. One value that says this is how much of something there is. Okay? A number can have multiple digits. Most numbers have multiple digits. A number can have a decimal. Doesn't have to have a decimal, but it can have a decimal. And a number can have a value from 0 to infinity. Now, this very, very rarely happens in science. But a number could also be what kind of value? What could you put in front of a number? Yes. A number can be positive or negative. Now, here's what I will tell you. Almost every measurement that you will make in this class has to be a what kind of number? Positive. You can't have a negative mass. You cannot have a negative length. You cannot have a negative volume. So we are talking about positive numbers, but understand there can be a negative change in something or things like that. So what's the difference between this number and the digits that make it up? A digit is a single value within a larger number. It is one of the digits within the entire number. In this case, there are 11 digits within this number. It is part of the number. It is not the whole thing. It is one part of the number in a certain place. Each digit represents that place within the number. The ones place, the tens place, the hundreds place. Or if we go to the right of the decimal, the tenths, the hundredths, the thousandths. Each digit represents that place within the number. What values can a digit be? Through 0 to 9. That's it. Digits are only 0 through 9 because they are one place within the number. If you talk about the number 10, it has two digits, a 1 and a 0, but two digits. So digits don't ever go higher than 9. They don't ever go lower than 0. You don't have a negative or a positive sign with a digit. The whole number could be negative, but a digit cannot. You're not going to put a negative sign in the middle of a number. All right. Questions? All right. Because I want to give you enough time to take the quiz, because I have never given a quiz on Canvas before, I don't know how this is going to go. We're going to find out right now. Okay. What I would like you to do is take out your periodic table, take out your solubility chart. Please put away your worksheet packet. Okay. And then your computer needs to be open. And your computer needs to be in Canvas right now. All right. Again, ladies and gentlemen, I am hoping this goes well. Not off to the greatest start. Let me find my quiz. It may not have posted yet because it may not be the right time. Let's see. All right, so let me refresh this. Does anybody see it on their computer yet? Because I don't see it on mine, but it's supposed to post at 8:10. I tried to just change it. It's now 8:10. We'll see what happens here. Vision Lab answer key. See, ladies and gentlemen, this is the wonderful part about Canvas and the teacher learning it as you guys are learning it for the first time. Thank you for your patience. Go ahead and give it a shot. We'll see if it works. Did it take your ID? Okay, you gotta find your number real quick.
Can I go in the back tables because I have to charge my phone?
Yes, go ahead.
Is this a quiz?
Yes, where are you at?
So I just went to a dashboard and then it should be like on the side.
Okay.
And you click on it.
Thank you, thank you, thank you. I love it when you guys are smarter than me. I really do. All right. So here is what Shining just told me. If you go to dashboard, it'll be up on this corner for you. It'll be the Unit 1 vocabulary quiz. Okay? So when you go to dashboard, go to that. Thank you. I was looking for it to appear somewhere else and it didn't. I'm sorry. Thank you for telling me that. So that is where you can begin the quiz, ladies and gentlemen. All right? If you need help finding it, please don't whine. Just call me over, raise your hand, and I will help you find it. Okay? But you should be able to get in it, ladies and gentlemen. Okay? If not, please raise your hand and let me know. I got 2 chargers right there. By the way, ladies and gentlemen, I have 2 charging blocks that sit on the front of my desk. If you need one when you come into class, please grab it and use it. Okay? Or ask me and I will go get. There are more in the back. Are you okay? There? No, what's the matter? You're not gonna fail. You know the first 6 points of the quiz.
No. Oh my god, I have to write it. It's not like a multiple choice.
I told you that you were gonna have to write the definition. Okay, so.
Oh, you didn't.
Okay, but there you go.
It went through. I just don't know how to cancel it. It went through though.
Okay, when you come back, you just type in your ID again and then.
Okay.
Okay.
So do I write that?
Is that the definition of chemistry?
Yeah.
Okay, but that's the question says define matter. What 2 characteristics
Oh.
does all matter have?
I'm slow.
Now, if you go down a little bit, you might get to the question that asks you to define
Okay.
chemistry.
Okay. Okay.
Right? Anybody need help finding it? Anybody need help getting into it?
We're still doing it.
You can't get your whole score back. I don't know. I don't know. When you're done, it will not grade the 2 questions that are the ones that you type in.
Okay.
So if it does give you a score, it's only giving you a score out of 12 points, or like 13 points instead of out of 20. Because I have to grade the 2 questions that you typed in the answer to.
Okay.
Use the process of elimination. So you answered 2 of them, right? Okay, so you're debating between the other 3. You should be able to eliminate some of them. Do the best you can. We have many, many, many quizzes and tests that we're going to
And
do.
this is the first grade.
So it is going to give you a score, ladies and gentlemen, and it's going to tell you so many out of 20, but please understand, I still have to grade 7 points on there. So when you get your grade, the best that it's going to be able to tell you is 13 out of 20. When I finish grading it, then it could go up from there, obviously. Yes. So again, it's going to be lower than it looks right now, so.
This is pretty much like the definition that they're asking. Is it in the definition?
Those things are in the definition, yes. Yep. When you're done, is there a submit button or something that you have to hit? Okay, please make sure you hit that and then it'll give you your score. But remember, your score is going to be lower. It is possible to be if it has
You go in my room and tell me if it smells like gas. I checked all the nozzles.
I didn't warn you on that.
I asked Megan and she didn't know either. Oh, sorry guys. It's mad.
I don't smell anything.
Okay.
I mean, there was like something when I first walked in there, but I don't think it's the gas smell.
Okay.
Light a match, find out.
Thank you.
Yep. Ladies and gentlemen, there are some people still finishing up, so please try to keep it quiet for them. Okay? If you're finished, ladies and gentlemen, in Google Classroom, please start looking over this lab safety presentation because we're going to have to talk about that and take your safety quiz as well. So click on that. There's a presentation there in Google Sheets that you can look at. Okay. If you looked at it when you had your asynchronous day, that's fine. Just glance through it again because we're going to need to talk about that. If you finish the quiz but you did not submit it, I will not get it. You need to go back in the quiz and submit it. Because until you submit it, it does not allow me to grade it. It does not send me a copy of it. So please make sure you submit the quiz when you are done. If you're having problems, call me over and I will try to help you. I will get your quizzes graded. Some of them I already have done. Obviously, your grades change dramatically when we add 7 more possible points to your grade. So, again, I'm new to Canvas. Hopefully, you can see it when I'm done so that you can see what it's like. Uh, Otherwise, ladies and gentlemen, we will talk about it tomorrow. Thank you. Again, remember, keeping track of attendance and things, so try to get here on time in the morning. They're keeping track even first hour this year. And tomorrow we will talk about Sig Figs. Get some of the things that we've been starting wrapped up. Have a great day, ladies and gentlemen. We'll see you tomorrow.
My favorite. Oh, my bad. What's up, Grandma?
Goodbye, goodbye, goodbye. Right? I think it's just a matter of you just misunderstood that one a little bit with the units. Okay. They will, your quizzes and things are going to get a little bit harder though too. So you got 19 out of 20. You did really well, right?
I'm not able to retake it though.
No, not with a 95%.
Okay.
I only do retakes on tests. That's all I do retakes on.
I think I just kind of misunderstood the
Yeah,
question.
I know. And that's why we do the quizzes, so that way when you get to the test, you don't misunderstand the questions on the test.
I mean,
Okay.
I could still make my grade go up a little bit, right?
Oh yeah, there's still, your tests are still the biggest part of your grade. And we haven't done any of those yet.
Okay.
Okay? All right.
All right.
Have a good one, Ray.
You too.